Okay, so this is just a few examples so that you can properly do these problems. It's going to be quick, so I'm just going to take the information they have here, and I'm going to build a two-way table with A and A prime, or not A, and B prime, and try to use the information they've given me. So this 0.4 is going over here because they said that was the probability of A. Probability of B is 0.45. So that's coming down here. Then they give me this probability of A given B. And so this is a given statement or a symbol. And so that means that what's the probability of A given that you're in the B category? So I draw that symbol into a fraction form, and I take the probability of B and I put it down below. And they're telling me that the probability of A given B is equal to 0.4. And so on the top portion of this is coming from this intersection of A and B, because when they narrowed it down to just A given B, they were only including this column. And so that is, well, I don't know what it is. Sorry about that color. I don't know what it is, so I'm going to put an X there. And then I'm going to solve this, and basically just use my algebra to multiply this side by 0.45, cancel those out by 0.45 on this side, and find out that X equals, well, 0.45 times 0.4 is 0.18. 0.18. So that is this intersection there. It's not the answer to my question. My question, or the answer to the question, is, are they independent? And since I found out that the intersection from the information they gave me is 0.18, I can turn around and ask, is this independent? That is the probability of A times the probability of B has to equal, it has to equal the probability of A intersect B for them to be independent. We just found out that the probability of them intersecting is 0.18, and when you multiply instantly the probability of A times the probability of B, which is 0.4 and 0.45, you incidentally get 0.18, so it proves that they're independent. So that's a yes. All right. Ooh, that was a lot on that one. All right, and then I'm going to leave the next one up to you. And I said I'm going to skip through on selected problems. In fact, those next 4 or 3. Events A and B are independent, so in this case they're telling me they're independent, which tells me that intersection is equal to the individual probabilities being multiplied. They're asking for the missing probability, so I'm coming over here and I'm going A prime, B prime, and putting in the information they give me. I've got 0.1225 right there. They tell me that the probability of B is 0.35, so I'm putting it down here. And then I'd like to know, I guess, well, eventually I'm trying to find this one. But from the information I've been given, I can find the probability of A. Because they said they were independent, that means that the probability of A times the probability of B is going to equal the probability of A intersect B. All right, so I've got the probability of A, which I don't know, times the probability of B, which I know is 0.35, and the intersection of those is 0.1225. And so with a little bit of algebra help, drop that in there, and then I can figure it out. So 0.1225 divided by 0.35 equals 0.35, and so that is the answer to, whoop, watch out, that's X. Therefore, the complement of X is 1 minus that, or 0.65, so that's my answer. All right, I'll just give you, I think in one of my classes we were able to get a little bit into this one. A prime, B, sorry, A prime, B prime, and they're telling me that the probability of A is 0.2. Now keep in mind, they told me they were independent. they told me the probability of A union B, which is this area right here, that's all of A, and then this is B, and that's the probability of the union of those two. So that's 0.44, it goes in that shaded area, or that highlighted area, but I don't know how it's split out. So somebody noted in one of my classes that, hey, this empty box here is 1 minus 0.44, so that's 0.56 over there. Okay, and you might be saying, I don't know how that helps me, but we know this whole thing is going to add up to the probability of 1, so I can back my way into this one. That's 0.8, do a little subtraction. And then I can do a little more subtraction and pop over here and get 0.24. I believe that adds up. Yep. All right, and so I don't know the intersection over here, so I'm going to put an X there, and I don't know this one either. And rather than put another variable there, I'm going to write it in terms of what I have. So I'm going to go over here to this 0.2 and say 0.2 minus that X has got to give me this value over here. All right, and then over here, I guess just for kicks, I don't know if I needed that or not, but down here, this is going to be X plus 0.24. All right, so I'm using that variable X to help define some other boxes that might be helpful. Now I'm going to go to they told me they were independent, so the probability of A times the probability of B is equal to the probability of the intersection of A and B. And so the probability of A was 0.2, and then times the probability of B. I have now written that as an algebraic expression, X plus 0.24, and that's supposed to equal X according to my chart. Now I just do a little distributive property, 0.2X plus 0.2 times 0.24. I should be able to do that in my head. Try to be quick here. Equals X. Now I'm going to solve for X by subtracting and subtracting 0.2. So, oops, sorry, wrong place. 0.2X, and so I end up with, I'm going to come over here, keep me inside my boundaries here. I've got 0.8X equals 0.048, and now I'm going to divide by 0.8, divide by 0.8, and I'm going to get X equals 0.06. Now this is certainly not the only way to do it, but it's one way to do it. So I hope that kind of opened your eyes a little bit to what you have to do. So we've covered this. We know this is the complement. This is still under the idea that they are independent. I believe that's in this. Yep. And so again, here they are independent. We've got the given statement. Maybe you can build two-way tables and answer those. Here they're asking 9 through whatever, that they're asking if they're independent. So you've got to use the information in the two-way table to prove or disprove independence. All right, give it a shot and take ownership of your AP Stat class, and you're building your knowledge. Thank you, and see you Monday.